Okay, so welcome everyone. Welcome to the second LinkedIn live session here. It's our intention and our desire to bring you topics from the industrial space. And the first topic we had a couple of weeks ago was on OPC, how it enables digital transformation. So the pace at which the industrial world is moving, traditionally a slow moving space, but really in terms of the technologies that have come in, and all of those seem to be colliding, coming together in a future that's not far away. So a lot of such technologies are really coming into our space, the industrial space. One such technology, if you can call it a technology, it's a standard, physically a standard for Ethernet APL, advanced physical layer. So that's the topic of our discussion today. And I have with me Jagjit PT, who's the head of our embedded COE. It's my pleasure to have him here. Jagjit is a self-proclaimed embedded nerd, but with a fantastic business acumen and market understanding. So I really look forward to having this discussion with him. Jagjit runs, of course, as I said, the embedded COE here. About 100, close to 100 people in his team doing fantastic work. Every time I walk into his cabin, I come out a more wiser person. And I hope this session is going to be equally helpful for you. So with that, welcome Jagjit. I look forward, and I'm sure we all look forward to spending the next 30 minutes with you.
Thank you, Anand. Thank you. So, a quick introduction from my side. So, I'm Jagjit. So, I've been heading the group a good amount of times, and we have almost 100 plus people working dedicatedly with us, both hardware, firmware, and protocols. And today we'll be having a live session about APL. So, let's have some interesting discussion.
Sure, absolutely. So we have 30 minutes this session, and I think we'll wrap up the major part of it in 25 minutes, have the last few 5 to 7 minutes for questions from people tuned in already. So Jagjit, let's get started with the first question, and just to kind of set the context, the obvious one, if you could help our listeners understand what is APL, the advanced physical layer, and perhaps from the context of how the world, the OT world, is different before APL and after APL, and given technologies, protocols like Profinet and other field buses exist. So what does APL really bring to the industrial space?
See, APL, again, it's an advanced physical layer, the full form of APL, and so precisely you can say it's an Ethernet APL. So this is a new physical layer interfaces to the process industry. So, process industry is driven by most of the process industry communications are 60% are driven by HART. So now this is an alternative solution for HART because this is a two-wire Ethernet connections, which is polarity independent, and again it is compatible with intrinsic safety. Intrinsic safety is something like that, which is exclusively designed for explosion-proof environment, so that this communication interface should not create any ignition. And the good advantage is that it can give 10 Mbps the speed to the field, and again it has a power over data. So basically, this two-wire can be your the communication interfaces, and it can carry power up to 500 milliwatt. That's all about the APL. If you ask me what exactly APL, and plus one advantage is that by making APL to the field with these two-wire interfaces, you are enabling Ethernet connectivity from field to cloud.
Okay. And like as I mentioned, with protocols, technologies on the OT layer, the field layer, already enabling some of those communications, especially one that comes to mind, Profinet. What's the need of APL? I understand you mentioned speed and you mentioned explosion, hazardous areas where Ethernet can now work. But is this such a big leap? Is it really going to have that impact?
Of course, because of course the industry is almost it's 40, 60 years old, but transition from those technology to the APL, definitely it will take some time. But of course, this is going to be a very big leap. The reason why I'm saying that, first of all, it's a two-wire connectivity and polarity independent. So if you see any other interfaces, it needs some standard certain connector, correct, or a certain mechanical connectivity is required. So in case of APL, even you can go with the normal screw terminal, which could be your normal electrical interfaces like that, you can connect it. That is one advantage. And second thing, as I indicated, on power over data and as well as intrinsic safety, and with all this easiness of design and development, that is also one of the advantage. And the third could be, since we are giving an Ethernet with this two-wire connectivity, and various physical layers are available, which is coming with the Mac, built-in Mac, so that you can work with any small microcontroller also into this feed. So imagine we are getting this two-wire connectivity based on IEEE 102.802.cg, based on single pair Ethernet platform. We are getting this two-wire connectivity and plus Ethernet to the feed. So the moment when you have an Ethernet, any Ethernet protocol is compatible with APL. So definitely this is going to be a revolution. So tomorrow, if you are using Profinet also can communicate over APL, or in that matter, Ethernet IP or Hard IP. So any Ethernet protocol again compatible with APL. So it's only a physical layer changes.
Okay, okay. So now, if you could help Jagjit tie that to the bigger narrative, with APL promising to have this uniform connectivity from sensor to the cloud, and perhaps
Mhm.
help realize the potential and the promises that Industry 4.0 potentially offers. Uh, Ethernet all the way, perhaps sensors able to connect seamlessly, in some more or less seamlessly, to the cloud. So if you can help tie this OT layer, this physical layer, to the bigger narrative of IoT for our listeners.
Mhm. So definitely OT IT layer integration is again always a challenge, because you have a vertical communication sensors. Maybe your device has to connect the multiple devices, and that will form a network. And same way it has to talk to the upper layer also. So in that perspective, definitely this APL. So when you see an automation pyramid, like imagine you have one connectivity from top, from your enterprises layer, which is your MES layer, to your sensor level. You are using a one technology, Ethernet technology. Only thing is that when it is coming to the field level, we need to have some certain Ethernet switches which is compatible for this two-wire Ethernet, that will enable connectivity to the field side. So definitely this is going to change the face of Industry 4.0, and that's also it's enable a lot of seamless data communication to the field, and with multiple protocols.
Okay. So you mentioned protocols, and I think you covered earlier also. If you could, I mean, one of the things that people probably want to see is, the, and we hear this a lot, of OPC could go onto it, Ethernet IP could go onto it. So what does it take? What does it take to, is it just, you just put the protocol on APL and it works, or is there some special work the industries or the OEMs who are implementing these have to do? What's the whole APL and protocol relationship here? Various multiple protocols.
See, there is no much overhead on the protocol side. See, as long as you're, this is that's what I'm repeating. It's actually a physical layer change. So you are when you talk about any of the protocol, except TSN is again a network protocol. I'll discuss about TSN. But definitely when it is talk about other protocol is always talking which is on the application side. So, and it doesn't matter what kind of interface you are going to use it. See, right now you are using a gigabit Ethernet, you are using a Wi-Fi, or you are using a 10 bar 100 Ethernet. These things are your the physical layer interfaces, which is specified based on your speed and as well as electrical specifications. So these are the only changes which is going to impact on the APL side. So rest remaining everything is intact. Like even doesn't matter which protocol you are going to use. Even you can have a basic internet connection also over APL. And
Okay,
second is that, of course, this is I think I missed to add this point, where the cabling length can be up to 1,000 meter, which is almost a 1 kilometer. So that is also one of the big advantage.
correct, got it. So, okay, because you mentioned the cabling length, maybe let's transition to talk some of the technical aspects of APL. We've sort of covered a little bit from a business perspective, the benefit it brings.
Mhm.
So, if you could help with the listeners, there are terms that we hear around APL, trunk and spur. You mentioned a little bit earlier about the switch. So there's the
Mhm.
power switch and then the field switch, and of course data and energy both on the same two wire. And importantly, if you can also share a little more with APL, Ethernet is now available in hazardous environments in an interoperable manner. So if you can
Hmm.
cover some of those technical aspects of what a trunk and spur, what are the switches, the role of switches, and how does the whole intrinsic safety get enabled in APL, uh, that could be helpful for us.
Yeah, so trunk and spur is something kind of a very it's a legacy term people are using in the process industry. So we can easily correlate that. So trunk is something like that. You have one common bus where say example you have a main electricity connection or main communication layer where you will be branching out multiple interfaces for a subunit. So the branch we can call it as a spur. So generally, when you talk about any of the Ethernet protocols, it's generally not follow the trunk and spur methodology. It will go for either star or delta, which is pretty much common in the network side. But when it is coming to the process, like especially the foundation field bus, it's based on trunk and spur. So you'll be having a junction. Maybe you'll be having a long the cable. It will be distributed across your factory, and from there you might be having a junction. From there you are deriving a set of connection for a specific sensor, so which is connected to the field and grabbing the data. So that is called spur interfaces. So there is one more thing I would like to highlight it here, because the trunk length is up to 1,000 meters. So when it is coming on the intrinsic safety side, it has a limitation, right? Because this has to the particular cabling has to do it in a hazardous area, so where explosion chances is more. So where we need to reduce our power, so the distance has reduced to 250 meter. So of course that's not a matter, because from the hazardous area you can have a trunk junction point, or maybe you can have an Ethernet APL switch. From there, power switch. From there, you can derive this small extension to the sensor. So you discussed about the hazardous area also. So with this trunk and spur, I can explain you. So the trunk is something maybe laid out in, or the cabling could be done in a safer side where you have a very less chance of explosion, where where I would say like that your power will be not limited at that level. But from your junction to the field, where is the spur length, which we are going to transmit a low power data, that's something we will minimize the power.
Okay, okay. There's one other term that we hear in conjunction with APL, especially the intrinsic safety part, the two Ys, the two-wire intrinsic safe Ethernet. Would you be able to cover a little bit on that? What does it mean?
TwoWire, as I indicated, I told you this is based on standard IEEE 802.3 CG, which is released in 2019. So this is something maintained by IEEE, and that is actually a single pair Ethernet. So based on the single pair Ethernet, the APL transition is something like that. That is exclusively there is an electrical specification for intrinsic safety aspects, which is the moment when I say intrinsic safety, the power to the field has to minimize it. So with this two wire as a differential pair connectivity, which is a plus and minus voltage, we can transfer the data to the field.
Okay, okay. Sure. I think that's good amount of technical information. If there's anything else you want to add, there's one point you mentioned earlier that you probably want to cover about TSN, and if we
Yeah.
could talk about that.
Yeah, TSN is again a new network standard called time sensitive network. So in that TSN, what happened? Basically, all your network right now, the one network standard is CSMA bar CD, where there is the data is not delivered on time. So imagine an automation network which is with the TSN and with this two-wire connectivity, and where you are transferring all the TSN again for to get compatibility with the TSN with other protocol. Definitely there is some application layer changes required on your protocol side. That is a separate topic. We can have a different session for that. But at least by enabling a TSN network to the field and connectivity over this two-wire Ethernet, definitely that is going to be the future, where you can have a time critical packet also you can deliver, especially when you're talking about robots or any special sensor data. So those things, the packet will be delivered in a critical timely manner. And again with this APL, since we are powering the devices to the field up to 500 milliwatt, we can power the sensors. So you are get rid of the extra power cable to the field. And second thing, by enabling a TSN switch, you are also ensuring that the time sensitive network, so that you can also have a critical communication network for your organization side.
Okay, okay, sure, sure. So let's now that we've understood a little bit of the background from technical perspective in business, if you could help us understand from an adoption perspective, given it's a new technology, new physical layer,
Mm.
and I understand it's not widespread now. So what is your assessment of what will it take for a broader market adoption? And I'm talking this from an end industry perspective, and also if you can touch upon what does it take for migration. People would not prefer rip and replace kind of migration, expensive migration. So if you can touch upon the 2 points, how far are we from a broad market adoption, and what are the challenges in the migration from whatever currently industries may be using to APL, physical layer.
First of all, the major the requirement or major need is something that the APL 5 should be available to the market. So the few companies are already released APL 5, and we are also using on our devices APL 5. So basically, to get from standard Ethernet to two-wire Ethernet. So yeah, as I discussed, since this is a two-wire Ethernet, when you go to the IT layer, definitely it is a standard Ethernet. So the network abstraction, which is from your two-wire Ethernet to a standard Ethernet, definitely you need an Ethernet switch, which I can say an APL switch is required. Where other end it could be a APL port, and on opposite side you can have a standard Ethernet to collect all this data and push to the IT layer. And the second thing, adoption to this existing industries, it's little tricky because your the installed system which is already into the market, or consider it's a DCS or any SCADA or any other PLC, which don't have any Ethernet APL port. So even though if your sensors are enabled with APL and intrinsically safe, definitely you need to have an APL switch or an APL two-wire Ethernet to standard Ethernet converter to connect with your the DCS, and that something could be a customized option. I'm not sure about any ready solution which is in the market. This is quite a challenge, but definitely the new installation which is going to happen in future, that maybe the entire network can be architect and the plan accordingly to fit this kind of things. And but I can see some traction from a few of our customers because they are also keen to implement this APL, especially the wall manufacturers and sensor manufacturers. They are coming forward or asking these solutions on APL side because at least they are capable, or they have an option to use an APL converter. I mean, it's moreover a two-wire Ethernet to a standard Ethernet converter. So like that, people are coming, but definitely I would say next 1 to 2 years you can see the change, and many DCS vendors also migrating to APL port. They will also provide standard Ethernet and APL port. With that, definitely we can see a change.
Got it, got it. And one thing for sure, I think people must already be aware, given that this is the same cable, the Type A cabling, I think that's what it's called. So on the field side, perhaps the same two wires that probably were used for some of the other field bus communication could be easily used for APL, right? Or is that
Yeah.
not correct?
Yes, yes, that's also an option. Like, say, example, already the entire plant, if they are using a heart, which is a two-wire connectivity, and the cabling is already done. Other end, of course, you can change the same cabling can be used, and they can use an APL sensor or an APL device at the other side. And same time, what happen? They can use this two-wire connectivity to the DCS system. Only the DCS system we may need an APL switch or a converter that will connect into maybe instead of hard interfaces, if they have an Ethernet port, we can convert it. Or if they still wants to convert APL into hard packet, in between we need to have some kind of a microcontroller processor-based system to grab this data and convert it back by meeting all the protocol complaints specification.
Got it. So because Jagjit, you of course mentioned, the DCS, the control systems, the microprocessors or something. So the natural next question is, of course, you covered about the adoption from an industry perspective. And now, what does it take for the OEMs or the product builders to implement APL, to support APL? What is the ecosystem that's available right now? I know it's early days for APL, but of course, I mean, it's mature days also. So what's the ecosystem right now? And then also, finally, if you can tie that thing to what does Utthunga also offer in APL, because of course we offer quite a bit services there. So first, if you can cover the general ecosystem, and then what is that, from your team, especially at Utthunga, we could offer.
See, ecosystem perspective, definitely, as I told, the one of the big challenges is that the field network compatibility, especially that's something from the DCS system or the SCADA or PLC, it should have a compatibility. But there is an increasing trend from our OEM side for converters. So majority of our the customer who is using HART, there is a requirement to take APL again. HART IPs, something which we can port it on top of it. So most of the people are asking kind of an adapter. So it's kind of an APL adapter that can fit on top of the existing PCB and take the data and convert into APL. That is on the feasibility side, and a few customers are migrating their entire design. I mean, maintaining their all the sensor related or actuator related operation. Retain as it is, only the interfaces change. Interfaces part they are changing, and they are also coming into such kind of decisions. And of course, from Utthunga side, we are also offering various APL hardware design, because intrinsic safety is something our core skill set, where we can design explosion-proof electronics. So with that, we can migrate the existing legacy device to APL, or the existing device we can have an adapter by considering all the certification standard to convert into APL. And of course, once it is converted, another DCS side and SCADA or whatever it is, it's required some interfaces to get this data also. And that particular custom design also we can do it. So, but at least we are happy to share that a few customers is already migrating to APL from especially from legacy devices, and that is a good sign.
Okay, okay. Good to know. Good to know, of course, of the ecosystem that's maturing and the adoption. I think we're pretty close to people seeing actual products in the market and usage, in the actual industries. So that's great. I'm not sure if I missed anything, Jagjit. If you did aspects that you think the user should know from the APL perspective, before we dive into questions from our listeners, if you want to cover anything else that we missed right now.
I think we covered most of the things, Anand, and I'm happy to
Okay.
listen any questions from anyone.
All right, so let me just quickly look at our panel for questions. So there are a few here. So I'm just going to read it out. It's a little long one. Generally, so the question, Jagjit, is generally what is the impact on cost of end devices when using APL over existing technologies? Is this negligible for field device manufacturers? For example, PoE, power over Ethernet, adoption has not been as widespread as expected due to costs associated with PoE solutions of switches cabling. So I think Nitin wants to know what is the impact on cost of end devices using APL.
See, the cost anyway, there is a straightforward answer, because the traditional Ethernet is in the 4 wire, and definitely when it is coming to APL, it is a 2 wire. So there itself, the cabling cost has come down. And second thing, there is no special kind of a connectors are required. So that is also one advantage, because generally it can work with any terminal, any two wire terminal it can work. So compared to PoE, the power over Ethernet, again the power over Ethernet is designed, it's a special electronics and other thing, that the cost part is a little bit high, and it is not compatible for the process industry, because it is again a power hungry device and power hungry gateways. But the moment when it is coming to the APL, this is extremely low power and it has only 2 wire interfaces. So for sure, cost perspective, this will be a low cost solutions, and there is no doubt compared to the existing PoE and other expensive PoE gateways.
Got it. Got it. Next question, Chajit, is how or where does the 4 wire to 2 wire Ethernet conversion happen? I guess what the person is Vamsi is trying to ask is, so you have the 2 wire at the OT side and you have 4 wire from the above. So where do the two worlds meet? I guess.
See, definitely, as I told, from field sensors, like definitely the sensors has to connect to the PLCs or SCADA, or in that matter for any DCS system. So if the DCS or your SCADA system is working on a standard Ethernet, definitely the sensor interfaces with this 2 wire has to convert into 4 wire. And of course, in APL, generally in APL, any of the topology, we can see an APL switch or an APL power switch. Generally, we can say that actually a device which is pumping power to the data line, so that is the transition is going to happen. So basically, you can say from sensor to your controlling element. If the controlling element is or controlling component is in the standard Ethernet side, in between we need a APL switch or APL power switch is required. So that will convert your two-wire APL to standard Ethernet.
Got it. Got it. Okay, thank you. Next question is, would like to understand what is the maximum power possible on the APL network?
Okay, so that is up to 500 milliwatt we can send the power to the field.
Okay, got it. Okay.
500 milliwatt, but that is again restricted. The 500 milliwatt is not compatible for intrinsic safety, but using APL definitely you can power this much power to the field. But when it is coming to intrinsic safety, based on the NTT parameters of the intrinsic safety, we may have to limit the power maybe 36 milliwatt to 23 milliwatt. But this particular interface is capable to do up to 500 milliwatt.
Got it. Okay. And so now just kind of getting some context to that. When you mentioned 500 milliwatts of power, right? Hello?
I think I lost in
You able to
between.
hear me? Okay.
Can you
So
repeat the question?
you mentioned 500 milliwatts of power, right, on the network.
Yeah, yeah, yeah.
So what does it mean? Like, from if we try to get a context, what kind of devices can it drive? That amount of power. Is it enough? Is it less? Is it what's the
Yeah,
stand?
yeah, because in a process automation perspective, that is enough. See, say example, as I told, the process automation is driven by heart, which is actually 4 to 20 milliampere. So actually, if you take your maximum current is 20 milliampere and your device is giving a 3 volt or something, maximum power is 50 milliwatt is coming to the field, right? Basically, that's a basically current and voltage equations. So I would say like a 20 into 5, how much it is coming. So that's a maximum power you are giving to the field. So from process industry, since this is targeting into the process industry, so 100 milliwatt is sufficient for this kind of devices. Generally, 100 and 150 milliwatt is sufficient. So even we have seen the positioner, which is a wall positioner, which is working less than 50 milliwatt. So the power what is available on this kind of APL or it is more than sufficient based on the current scenario. But there is an increasing trend in machine learning or data processing. Of course, our sensors and actuators become more smarter, and they need a more processing power. So definitely, this 500 milliwatt is sufficient to do that with comparing with the current the power demand.
I got it. Okay. Great. There's one basic question, something that even I struggle with when starting to learn about APL. What's the difference between SPE and APL, the single pair Ethernet and APL? So, if you want to cover, I know they are poles apart, they're different things, but I think it's easy to confuse if you read up a lot online. So, if you could cover that.
Yeah. SP is basically an Ethernet standard for two-wire connectivity. Okay, so that's what I said, that the standard is IEEE 802.CG. Even APL is also derived based on that standard. So based on single pair Ethernet standard, there is a consortium by working all these leading companies. They come up with a more specific need for advanced physical layer exclusively for process automation. So which means that this particular specification consider a lot of detailing aspects, especially the intrinsic safety aspects and the power delivery to the field. So those things are considered on the APL side. SP is only a specification of two-wire Ethernet as a physical layer specification. When it is coming to APL, it cater all the power delivery to the speed and the topology aspects. All these things will cover in the APL aspects.
Got it. Great. That was helpful. So let's just use the last question. We have 2 minutes remaining. So the person asking, "Hey Jagjit, can you throw some more light on how does TSN and APL function together?" I think you covered this, but maybe if you can just
Yeah,
shed
maybe
some more
quickly I
light.
can cover because TSN, again I said it's a network standard, it is a physical layer standard. So maybe you can have a TSN enabled APL also in future. Say example, you have critical sensors which has to update that update in every certain fixed amount of time to a gateway or to a DCS system, definitely TSN enabled APL will definitely suit for that. Again, TSN is a network standard, APL is an electrical specification, which is a physical layer standard. So you can have a TSN APL together, which will coexist. Yeah.
Good, good. Great, great. I think that's all the time we have. We are at the 29 bottom of the half hour, pretty much at the end of the half hour mark. So, well, thank you, Jagjit. Thank you for sharing your thoughts on APL and enlightening us to understand it really from a practical perspective, business perspective, technical perspective. I hope this session was helpful for everyone here. Feel free to get, you visit our website. We've got some information there. We've done some webinars in the past. Go to our YouTube channel. You could just search us on the YouTube channel by our name, Utthunga, or just search on the YouTube directly. So you'll get some information there as well. Or if you need more information and want to have some in-depth discussion, feel free to reach us at contact@utthunga.com. It's contact, CONTACT, contact@utthunga.com. So that's it. Great. Thank you very much once again. Thank you again, Jagjit.
Thank you, Anand, and thanks for the audience. Thank you.
Great. All right. Have a good rest of the day, everyone, and a good weekend wherever you are. Bye-bye.